This tutorial is the first part of a two-part video explaining mat foundation design using STAAD Foundation Advanced software. It will cover up to the analysis of the mat model, including mesh generation and design parameter specifications. The second part will cover everything after analysis. Conventionally, mat foundation is by far the most complex and ambiguous type of foundation to design, as you can see by viewing the expansive mat foundation job section in the main navigator. STAAD Foundation Advanced provides a streamlined user-oriented approach to model and design the mat foundation. I will open the example isolated foundation file. Then go to Create a new job under Job Setup to create a mat job using the supports and global data from the isolated job. A job name is required to potentially differentiate between multiple mat jobs in the same file. Select mat as the job type and change other job info if needed, like design code, default unit type, and code version. An important step is to choose which supports will be a part of the mat foundation. I will select Assign to all the supports for this example. If you wanted to assign the job to a specific few supports, use either the Assign to Selected Supports or Assign to Listed Supports tools. Then select the service and ultimate load cases which will be used for our design. Usually these are just the load combinations. Finally, create job. You will see in the main navigator a new set of options called Mat Foundation Job. It can be expanded to show the mat design parameters. Unlike any other module, mat foundation is based on finite element analysis, or FEA. So, a mesh generation is necessary to break up the mat slab in a finite number of elements, in this case plates. I will first set up the mesh using the Add Rectangular Region tool in the Add Meshing Regions section. Circular or polyline options can be used as well to create the mesh. The meshing or mat boundary can also be added using the graphical interface by going to the Tools tab, then Create Mat Boundary by Polyline. The user must use grid intersection points or column nodes to create mesh using creation tools outside of the main navigator, like this. It's helpful to reference the column positions when creating the mesh region. I will just fill in some values for the mesh. Then go to Meshing Setup to generate the mesh. Have the mesh region selected and give it a region identifier. Then click Add. If the region is a hole or control region, select the appropriate region type. These control regions can be used to create one or more slab regions with different thicknesses and/or different soil properties. Enter the target maximum, which is the maximum allowable plate dimension size. Also, the user can select Optimize based on area, which is only applicable to triangular meshing. While the region is still selected, press Generate Mesh to bring up a Meshing Options wizard. The user can choose between quadrilateral, mixed quad and triangle meshing, and triangular meshing. Quadrilateral meshing is the best option for regular rectangular or any regular convex polygonal shapes, while mixed quadrilateral and triangular might be better for irregularly shaped meshing regions. The triangular option should only be used when pure quadrilateral and mixed quadrilateral and triangular mesh cannot be generated. Select Create Node at the column support positions if you want to create a node right beneath the support position, which might result in a better load distribution for analysis. The optimization level controls how optimized the mesh is. A higher optimization level will take more time to process, but the internal angles of the quadrilateral plates will be closer to 90 degrees. Internal node spacing factor controls the spacing of nodes. The node spacing factor is a trade-off between accuracy and practicality. When done, select OK. In some cases, the engineer should use their experience to check the quality of meshing and may want to check meshing parameters to regenerate the mesh as needed. The mesh is now generated. I will create a hole with a circular region as well to further show this concept. After the hole is generated, you must remesh. Regions can be edited or deleted using these buttons. Next, enter slab analysis and design thickness for design. If the mat foundation is going to be supported by soil, go to the soil properties and check Use Soils and enter the subgrade modulus. If you want to consider soil weight on top of the mat, soil density and soil height should be specified. If the mat job will be supported by piles, then go to the Pile Layout section to create the piles. There are 3 ways to create piles here. The first is to manually input the coordinates of each pile in the pile position table. The other 2 are parametric creation wizards for rectangular and circular pile arrangements. These 2 pile arrangement wizards are similar. For rectangular, first specify the origin, and then the number of rows, number of columns, row spacing, and column spacing. The table shown gives the row or column spacing. To toggle, select either row or column spacing. Press Apply to apply the arrangement. The circular pile arrangement wizard is similar, but instead specify the number of piles, number of circular layers, and pile spacing. After using one of the arrangement wizards, the pile positions can still be edited using the pile position table. Drag select any number of piles and press Delete to delete these piles. Beams can be added between footings in the mat job using the Add Beams tool under Tools in the Home ribbon. I will create one between supports 1 and 2, and then add a mat-specific uniformly distributed load along the whole distance of the beam. It must be added to a load case and then assigned to the job. The Default Properties section lists a variety of design parameter values that apply to its corresponding object. For example, if you enter default pile spring values along the X, Y, and Z directions, when a new pile is created, it will have these pile spring values. Other default values like slab analysis thickness and subgrade modulus will only be applied when a new mat job is created. Once the mesh has been created and analysis properties completed, click Analyze to analyze the mat foundation. This video will continue in the second part. Thank you for watching.